Hello, in this video we are looking at the concept of linear inequalities in one variable. So by the end of this tutorial, we should be able to identify linear inequalities. We should be able to find the solution of linear inequalities with one variable. We should be able to interpret the solution of linear inequalities on a number line. We should as well be able to find the range of value that satisfy two or more linear inequalities. My name is Ademola Folari. This video is powered by IOTA Virtual Learning. Let's start. When we say linear inequalities, this is just as similar as our linear equation. But in inequalities, the equals to sign in the equation will change to inequality sign. Take for example, we have 2x plus 5 equals 9. This is a linear equation. But if we are to transform this to linear inequality, it becomes 2x plus 5. We now substitute this equal sign with inequality sign, either by saying greater than, or we say less than, or we say greater than or equals to, or less than or equals to 9. In such, it has become linear inequalities. So greater than, the sign here, less than, greater than or equals to, less than or equals to. These are signs that we are familiar with before now. So when we have two expressions in which they are being compared to each other using inequality sign, we say we are dealing with linear inequalities. Linear inequalities are inequalities that involve at least one linear algebraic expression that is compared to another using the sign of inequality. Now we all know what linear inequality is. Let's proceed to solving problems involving linear inequalities. Here we have this problem that says we should solve the following inequalities. To solve these inequalities, in solving this inequality, this is less than or equals to. In solving these inequalities, we must put into consideration two things that makes it different from linear equation. When solving linear equation, we know the steps to take. However, in inequalities, instead of having equals to sign, we have inequality sign. Also, for linear inequalities, whenever we are multiplying or dividing any term by negative number, the sign will change. Let's try that out for the problem before us here. Number 1, we have 3 open bracket, 3 open bracket, x minus 5 greater than 6. So we are to solve for the value of x and put it on a line graph. To do this, just similar way that we approach our linear equation, we open the bracket, it becomes 3x minus 15 greater than 6. Then the next thing for us is to collect like terms, becomes 3x greater than 6 plus 15, which leads us to 3x greater than 6 plus 15, that's 21. Then we can divide both sides by 3 so that we can obtain the value for x. So x will be greater than 21 divided by 3, x will be greater than 7. So what does this mean? It means for this inequality, the value of x that will satisfy this statement must be greater than 7. Now let's put it on a number line. To put this on a number line, let's say we have the graph drawn this way, and if we are dealing with something greater than 7, let's just say this is 0, this is the graph of x. So if we have this as 7, 14, and so on, this basically tells us that x is greater than 7. That is, the value that satisfies this condition for x must be greater than 7. And that is how we represent it using number line, saying x greater than 7. Fantastic. Let's look at the second problem. For the second problem, where we have 2x minus 2 less than or equals to 19 plus 5x. Just our normal way of solving linear equation problem, we collect like terms. It becomes 2x minus 5x less than or equals to 19 plus 2. So this gives us negative 3x less than or equals to 21. Here, we are going to divide both sides by negative 3 so that we can obtain the value for x. Recall, in linear inequalities, when we divide by negative number or we multiply by negative number, the inequality sign will change. So we are having here negative 3x divided by negative 3. The inequality sign becomes greater than or equals to 21 divided by negative 3. And we are left with x greater than or equals to negative 7. So this statement means whatever value of x that must satisfy these given inequalities, that value of x must start from negative 7 or greater than negative 7. That is, it starts from something of minus 7, minus 6, minus 5, and so on upward. Now, let's put it on a number line just as we did the last one. So if this is 0, negative 7, 7, this is x. Because it's from 7, negative 7 upward, choose this. Now, it starts exactly from negative 7. So negative 7 is included. Because it's inclusive inequalities, we have to shade this part. Unlike this part where positive 7 is not included. Because it's inclusive inequalities, we shade that part. X is greater than or equals to negative 7. So we've been able to solve these problems and as well place them on a line graph. Isn't that interesting? Yes, fantastic. So let's move on to solving other problems under linear inequality. Problems such as this. we are to find the range of value of x which satisfy this condition. Problems such as this, we are to solve the inequality given to us here. To solve this inequality is similar to solving our linear equation problem. So let's look at it together. The question says 1 plus 4x, that's 1 plus 4x divided by 2 minus 5 plus 2x divided by 7 less than x minus 2. Although there are several ways of approaching this, in a simple way, let's look at the LCM of 2 and 7. The LCM of 2 and 7 will give us 14. So can we multiply 14 by each term in the inequality? Multiplying 14 by each term in the inequalities, we have 14 multiplied by 1 plus 4x divided by 2 minus 14 multiplied by 5 plus 2x divided by 7 less than 14 multiplied by x minus 2 divided by 1. So what we have done here is that we have looked for the LCM of 2, 7 and 1, which gives us 14. Then we multiply each of the terms by the LCM. So this one becomes 7 open bracket 1 plus 4x minus 7 goes here 1, 7 goes here 2, 2 open bracket 5 plus 2x less than 14 open bracket x minus 2. We can then open the bracket to say 7 plus 7 multiplied by this, we have it as 28x. Negative 2 multiplied by this, that's 28x. Negative 10 multiply this, negative 4x less than 14x minus 28. So moving forward, we have to collect like terms. Collect like terms. So let's put the sign here. The ones involving x, let's pad all of them to the left hand side, starting from 28x minus 4x minus 14x. So to the right hand side we have negative 28 plus 10 minus 7. So from here, if we try to do this, that is 28 minus 4, 28x minus 4x minus 14x, that should give us 10x less than this. Subtract 7 from 10, you are left with 3. Add 3 to negative 28, we are left with negative 25. So here now we can divide both sides by the coefficient of x, which is 10. We have 10x divided by 10 less than negative 25 divided by 10. So we have x less than negative, what we have here, we can say 5 goes here, 5 goes here 2, which is either we leave it here or we move further to say x less than negative 2 whole number 1 over 2. And we can say for the above inequalities, the value of x that satisfy the statement must be less than negative 2.5. So what are the value of x that are less than negative 2.5? Starting from negative 3, negative 4, negative 5, negative 6, downward. That is a question from WAEC 2019. I bet you enjoyed this. So don't forget to subscribe to this channel and follow us for more interesting educational videos like this. Thank you.